Hello, ladies and gentlemen, and welcome once again to our virtual classroom. Today, it's going to be a little different in that I am simply going to go over the assignment and just to give you some examples so that you can observe how it is that I'm working through these. I'm not going to do all of them, but I do want to do a few of them along with you. Let's begin with these two word problems right here. By the way, the problems that are assigned, so this is activity 14. You're going to be doing numbers 4, 6, and then 8, 10, numbers 16, 18, and 20. So I encourage you to pause this video and just copy those down. And then you're also going to be doing numbers 32 and 34, numbers 32 and 34. So again, I encourage you to pause the video while you copy down on your paper that you're going to upload to OneNote what numbers you're supposed to be doing. All right, let us begin with number 4. All right, number 4 reads, a 1,000-pound horse eats about 25 pounds of hay a day. How many days would it take the horse to eat 400 pounds of hay? Hey, that rhymes. I just realized that. Anyways, so let's circle the important information, same as we would do with a warm-up. So we have a 1,000-pound horse. Some would be tempted to circle the 1,000-pound, except that it's just talking about the horse. Okay, so the horse eats 25 pounds of hay a day. Or you might as well say per day. In other words, in one day he eats 25. In 2 days he eats another 25. That's 50. In 3 days he eats another 25. So that's 75. So in essence, ladies and gentlemen, we're doing the same thing: 25, 25, 25, multiple times. And just as I said that very specifically, because whenever we're doing the same thing over and over again, we are multiplying. We're doing it multiple times. Multiplying times. Don't we say times whenever we are multiplying, because we're doing something multiple times? So it would be 25 times the number of days. We don't know the number of days. Let's see what the question's asking. How many days? So there you go. We don't know the number of days. Um, that is our variable. Anytime they say how many of something or how much of something, you know that that is what we're looking for. That is our variable. So how many days would it take the horse to eat 400 pounds of hay? The first thing we want to do, and you'll find that in number 4 on Schoology, there's going to be 2 parts to it. The first part is we have to build the equation. It's going to say blank x is equal to blank. All right, and then on the bottom is going to say, and then it's going to say x is equal to what? All right, so first let's build the equation. All right, so again, this is number 4. And again, we're trying to get to 400 pounds. And we know he's going to eat 25 pounds, but he's going to be doing that for multiple days. So I'm going to multiply that times the number of days, and that's what I'm looking for. So whenever you put this on Schoology, it's going to be 25 x is equal to 400. That is my equation. Now let's find out the value of x. And to do that, ladies and gentlemen, we're going to ask ourselves the same questions we've been asking ourselves for the last few weeks. What are we trying to do? What is our goal whenever we're working with equations? And that is that we're trying to isolate the variable. We want this variable right here to be all by itself. It is not by itself right now because I am multiplying it times 25. That is the operation that I have here. I have x times 25, or 25 times x. So how do I isolate the variable when I'm multiplying? What is the opposite of multiplying by 25? The opposite of multiplying by 25 is to divide by 25. All right? Because if you multiply by 25 and then you divide by 25, it's like you did nothing. You did the opposites. Another way to think about it is I have 25 over 25, 25 divided by 25. That's going to give us 1, and 1 times x is just x. The variable is now isolated. However, whatever I do to one side, I must do to the other. I must divide 400 by 25. 400 by 25, that is going to be 16. Therefore, ladies and gentlemen, x is equal to 16. All right. This will make way more sense once you actually see it in Schoology. In fact, I can show you. Here it is. Notice how it asks, well, what's the equation? Then you're going to fill in the blanks. So it would be blank 1. That would be 25. X is equal to 400, that's my equation, and x would equal to 16. That's how you would fill that in. And number 6, we're going to do the same thing, except that the problem is a little bit different. Let's go ahead and do number 6. I'm going to do number 6 over here on the side. Number 6 reads, 3/4 of the students in honor algebra are 8th graders. There are 21 8th graders in honors algebra. How many total students are in honors algebra? Let's circle the important information. We have 3/4, so that's 3/4 of, ladies and gentlemen, remember that whenever we have the word of next to a fraction, that usually means multiplication. So 3/4 times whatever follows the students in honors algebra. 3/4 times all the students in honors algebra, which we don't know how many those are 8th graders. Anytime you say something is or these things are and is another way of saying equals. So it's like saying 3/4 times the students in honors algebra equals to the 8th graders, which do we know? Yes, we know how many 8th graders there are. So that means that 3/4 times the students in honors algebra, which I don't know how many those are. Notice how the question is asking, well, how many students, total students in honors algebra? 3/4 times the students in honors algebra is going to be the 8th graders, which is going to be 21. That is my equation. So therefore, on Schoology, that is how I'm going to fill it in. 3/4 x is equal to 21. Now let's find out what our solution is. Let's actually solve this. Ladies and gentlemen, don't let the fraction freak you out. We're going to solve it the exact same way. Remember, our goal is to isolate the x. And why is the x not isolated? What is currently happening right here? Well, we're multiplying it times 3/4. How do I get rid of multiplication? Let's divide. Instead of multiplying by 3/4, we're going to divide by 3/4. That cancels out. And whatever I do to one side, I do to the other, 3/4. X is now isolated. X will equal to whatever 21 divided by 3/4 is. Here, ladies and gentlemen, you have to remember how to divide fractions. When you're dividing with fractions, you have to do K, C, F. So we're going to keep the 21, change the division to multiplication, and then flip the fraction into its reciprocal, 4/3. All right. Well, but this is still a whole number. What do I do, Mr. Lugo? Guys, whole numbers, remember, numbers are always, if there's no fraction, it is always over 1. The 21 is the numerator, 1 is the denominator. Let's go ahead and solve this. 21 times 4 is going to give me 84. 1 times 3 is equal to 3. So x will equal to whatever 84 over 3 is. Let us simplify that, or you can just divide. It's the same thing. 84 divided by 3 is going to give me 28. And that would be my answer for number 6. Pretty simple, right? All right, now for numbers 8, 10, 16, 18, and 20, we're going to follow that same process. Look at number 8. 7 times x is equal to 42. Let's isolate the variable. How do I get rid of multiplication? We divide. So I'm going to divide by 7, but whatever I do to one side, I must do to the other. 7 divided by 7, that cancels, leaving the x isolated. 42 divided by 7 is equal to 6. So that was super simple. Do the same thing for 10, same thing for 16. Now in 18, ladies and gentlemen, don't let that freak you out. Notice how number 18, I'll just do this right here. We have 350 is equal to 140 R. All right, now notice how the variable is now on the right side, but that's all right. Let's isolate the variable still. Notice how we're multiplying to get rid of the times 140. We're going to divide by 140. And whatever I do to one side, I must do to the other. So I'm going to divide this side by 140 as well. R is now isolated. It doesn't matter that it's on the right side. 350 divided by 140. You can work that out on your own. It will give you a decimal. But that will be what R is equal to. All right. It doesn't matter if it's on the other side. It's the exact same thing. All right. Lastly, let's go through number 20 before we move on to the division problems. Look at number 20. Number 20. we have 1/5 k is equal to 15. Now, ladies and gentlemen, again, just ask yourself the same questions. What is my goal? I need to isolate the variable. So the case here on the left side, I want it to be by itself. It's not by itself because I am multiplying by 1/5. So to isolate the variable, we're going to use the inverse or the opposite operation. So the opposite of multiplying by 1/5 is to divide by 1/5. So I'm dividing this whole side by 1/5. 1/5 divided by 1/5 is 1. K is not isolated. So now let's do the same thing to the other side. Whatever I do to one side, I must do to the other. So I have to do 15 divided by 1/5. When we divide fractions, we do keep, change, flip. So I'm going to keep the 15, change the division to multiplication, and flip this fraction to its reciprocal into from 1/5 to 5/1. Now we just multiply. 15 times 5 is 75. 75/1 is just 75. So k is equal to 75. Now, in the last two problems, you'll notice that we have division, but we're going to ask ourselves the same questions. We have r for number 32, r over 6, or r divided by 6 is equal to 9. I need to isolate the variable, so I'm going to do the opposite of what I'm doing to r. The opposite of dividing r by 6 is to multiply r by 6, right? Even mathematically speaking, notice how I have a number on top and it's the same number in the denominator, so that's going to become a 1. 6 divided by 6 is 1. R will equal to whatever 9 times 6 is, because whatever I do to one side, I must do to the other. R is equal to 54. Notice how if you check this, it's going to give you, it's going to make sense, because if instead of an R, if I substitute the 54 in here, 54 is 54 divided by 6 equal to 9? It is. It works out. Ladies and gentlemen, you will do the same thing for number 34. I hope you found this helpful, and I hope it's good practice. And if you have any questions, please feel free to send me a message on Schoology or via email. And ladies and gentlemen, I will see you next time.